Hello now, welcome back. We're going to be talking about some basic antiderivative rules or basic integration rules. You hear me say antiderivative and integration interchangeably, and I apologize if that sounds confusing. For our intents and purposes, they'll mean the same thing. So let's review. If I took the derivative of any constant, we'll say 5. We know that the derivative of a constant, everybody, was 0. So what would be the antiderivative of a 0? Well, since we don't know what the constant actually is, we can just represent it as any constant, c. So when you have 0 dx, it's going to be any constant is going to be the antiderivative. How about when we took the derivative of a coefficient times x? What was that equal to? Well, it was equal to just whatever the coefficient was. So the derivative of 2x is equal to 2. Alright, so let's go the reverse. What's the antiderivative of 2 dx? Now, this part, the integral symbol, and the dx are like bookends in our problem. You can't have one without the other. So make sure they come together. So what is the antiderivative of 2 dx? That would be 2x plus c. C is called the constant of integration. Constant of integration. Because remember, if we took the derivative of 2x plus c, we would get just simply 2 back, because the derivative of c would be 0. Alright, so some basic things there. So what if we take, let's think about this, the derivative of 5x to the 6th power. Ooh, we know the derivative of that. 6 times 5 is 30, x to the 5th. Good. Well, what if I had to take the antiderivative of 30x to the 5th dx? How do I get it back to 5x to the 6th? What would be the rule to get us back there? Remember what we did with this. We take this, we multiply by the coefficient, we subtract 1 from the exponent. What would I do now to this? Well, if you thought, let's add 1 to this exponent and divide by that new exponent, you would be correct. So you would get, I'm going to put it right underneath here. Actually, no, I'm not. Move that over. We're going to get 30x to the 6th, and we're going to divide it by the new exponent. Don't forget our plus c, or you'll get that wrong. Well, look, what's 30 divided by 6 is 5. X to the 6th plus c, exactly what we started with our derivative. So think about that rule, that basic rule of integration. So think about that if I was going to take the derivative of any x raised to the n, what was the formula? Nx to the n minus 1. Well, what if I took the antiderivative of x to the n? So again, you're expecting me to put this in there. Well, that I would just end up with this. But if I have any type of integral, what is the formula going to be? Well, we're going to take whatever our x is. We're going to take our exponent. We're going to add 1 to it. And we're going to divide by that new exponent. And we can't forget our plus c. So it's a basic integration rule. If you remember back when we did derivatives, we had a chart where we had to write out, we had the derivative, the function, we had to maybe rewrite the derivative, take the derivative, and then simplify. We're going to have a similar type of situation for here. We're going to have the same kind of thing. So for example, if we have the integral of, say, let's start with square root of x dx. Now we are going to find a function who has a derivative of this, but we're going to use our basic integration rules, specifically this one right here, the power rule for integration or antidifferentiation. So what am I going to do? Well, I'm going to rewrite this first. I'm going to rewrite it as x to the 1/2 dx, and then I'm going to apply that rule. We have our exponent. We're going to add 1 to it. So in this case, we're going to add 2 over 2. So we're going to get 3/2, and we're going to divide by that new exponent, which is 3/2 plus c. So we have our integral, or our antiderivative, we rewrite it to something we can use, and then we actually find, now we have to simplify. So how do we simplify this? When we divide by a fraction, we multiply. We know how to get this square root of x cubed all over 3 is one way to write it, and we are done. Let's try another one. 1 over x cubed dx. What function has a derivative equal to this? Well, you're not supposed to be able to figure it out like our Jeopardy game last video. We're actually going to have to apply the rule. So let's rewrite it. How do you think we rewrite this first? You should be thinking in your head. You should say, we have to write it as a negative exponent like that. And that would be true. If you notice, I'm showing good form with my integral symbol and my dx. So now we're going to apply that power rule of integrals, or antiderivatives, by adding 1 to the exponent, dividing by the new exponent, and when we simplify, we get 1 over negative 2x squared plus c when we rewrite it. How do we check to see, is this really right? Is this correct? How can we find out? We can take the derivative of these antiderivatives, and we should end up with what we saw in the beginning. So if we took the derivative of 1 over negative 2x squared plus c, we should, if we did it correctly, get 1 over x cubed. Well, is this limited to just single monomials? Absolutely not. We can look at, and there's our kind of review of what we're talking about. We can have 5x squared plus 2x dx. And we could rewrite it if we need to. In this case, we don't need to rewrite it. We can integrate it. Remember, when we integrate, we actually drop the antiderivative and the dx. So we have our exponent of 2. So now we're going to have our 5x, add 1 to the exponent, and divide by the new exponent. Same thing. What's our exponent here? 1. So we add 1 to it, divide by the new exponent, plus c, we can't forget. And then our last thing is to simplify. So when I simplify, this can be left just the way it is. And the 2's are divided out. We're left with x squared plus c. If you don't believe me, check it out. If I took the derivative of 5x cubed over 3, I would get 15x squared over 3, which ends up becoming 5x squared. And the antiderivative, or the derivative, I'm sorry, of x squared is 2x, and that's where we started with our integral. So think of all of our derivative rules that we had, all those ways to rewrite things. And guess what? They're going to apply in a very similar situation as this. Let me give you a challenging one here. I want you to pause it and see if you can't figure this one out. Look at this guy. X plus 1 over the square root of x. Wow, dx. The numerator is x plus 1 divided by the square root of x. How are we going to do that? Pause it, try to figure it out before you continue. Hopefully you're back now with the answer. And the way I would have done it is I would have broken it up into something like this. And then we could rewrite this. This is x really to the 2 over 2. So what I did is I broke it up into the denominators. I split the denominator, so it's x over the square root of x plus 1 over the square root of x. And then I simplify the exponents from here. So this ends up becoming x over the square root of x just simply becomes the square root of x, or x to the 1/2. And this becomes x to the negative 1/2. That is 1 over the square root of x becomes x to the negative 1/2. Now we can apply our power rule for antiderivatives, integrals, however you want to call it. You'll hear us, again, using it both ways. And you add 1 to the new exponent, divide by the new exponent. So you end up with x to the 3/2 over 3/2 plus x to the 1/2, adding 1 to the negative 1/2 over 1/2 plus c. And then simplify it one last time. And when you do that, you know what you should get. And I'm going to move this over a little bit so you can see it. Oh, perfect. Perfect. So simplifying this, we end up with 2 over the square root of x cubed over 3 plus 2 times the square root of x plus c. Don't forget your constant of integration plus c. So again, we went over some basic integration rules. Next class, you are going to see that you are going to be practicing all of these basic integration rules. And if you can remember and find that derivatives chart that we had way back in the beginning of the year, it might help you in kind of seeing. But again, don't forget to integral the integral. We rewrite it if we have to, getting rid of maybe getting some negative exponents or getting things out of the denominator, getting radicals out of there. We integrate it using our rule, and then we simplify. I hope you enjoyed this video on antiderivatives and the basic integration rules or the basic antidifferentiation rules. Johnstone out.